Today we will going to see the second part of the hypothesis testing. So in this we will see about the distribution of the test statistics and the uh, testing hypothesis related to the population parameters and testing the comparing of parameters of the two samples. So see, when I talk about the distribution of the test statistics, say the distribution of the test statistics I am already taught in the sampling distributions. Okay, so you will see the sampling distribution lectures where I have uh, where I have taught about the z distribution, z test, t test, chi-square test and f test. Okay, here we will see that when the I have sorry, 1 minute. I have just said that when it will follow, when the test statistics will follow the standard normal variance or student t distributions, chi-square distributions, f distributions. So you will see that lectures in that I have just already just, for example, say if x follow the normal 0 1 and y follow a chi-square distribution with n degree of freedom, then x divided by under root of y by n will follow the t distribution with n degree of freedom. These types of concept I have already taught in that lecture, so you can see that. Okay, but today I will like I will teach you about the testing hypothesis related to the population's parameters. Testing hypothesis related to population parameter and the test of the, and the next is what, yeah, and the next is test for comparing parameters from two samples. Okay, so testing hypothesis related to population parameter. So in this you will have to test using the t test, z test and etc. Okay, so let me show you some of the okay, so first of all, suppose t test for single mean. Okay, what is this? So suppose you have a random sample, that is x1 to xn of size n, drawn from normal population with specific mean, say mu naught. Okay, the sample mean, it differs significantly. Okay, so the sample mean is given, that is sorry, not the population mean is given mu naught. So what will be the t statistics here? So the t statistics will be here x bar minus mu naught divided by s into under root n. What is s here? S here is your sample variance, that is calculated upon xi minus x bar square. Okay, and what will follow? So it will follow t distribution with n minus 1 degree of freedom. We will see some of the examples so that you will know much better about it. Okay, I am just giving you a short overview. So let me give you an example. Suppose a machinist is making engine part. Okay, I will not write the whole question, I will write only the important data. Okay, so a machinist is there making the engine part with axial diameter of 0.700 inch. Okay, a random sample of 10 part shown that the mean diameter of 0.742 inches with a standard deviation of 0.04 inch. Okay, see, a random sample of 10 part shows a mean diameter of 0.742 inches with standard deviation of 0.042 inch. Okay, now what it asks, compute the statistics you would use to test whether the work, means you have to compute, sorry, compute the statistic you would use to test whether the work is meeting the specification. Okay, see, all the required information is given. What the sample, sorry, population mean is given, that is 0.700 inch is your axle diameter. Sample diameter is given, sample mean is given 0.742 inch. Your sample variance is given 0.040 inch, sorry, sample standard deviation, and your number of sample is 10. How will you perform the, so what is your null hypothesis here? Since it is given that you have to compute the statistics would you use to test whether the work is meeting the specification. So how will you test that the work is meeting the specification? By comparing what is, like your mu is equal to 0.700 against the alternate hypothesis, mu is not equal to 0.700. Why we are using totals? Because we don't have any other informations regarding the alternate hypothesis. If in questions it is given that that the mu is greater than 0.700 or mu is less than 0.700, then we will use the one tail test, but here we will use the total test. So what is the test statistics? So the test statistics is what? X bar minus mu and divided by under root s square upon n. Okay, that is a capital S square. Okay, and here it is 1 minute. Okay, so what is x bar here? X bar is what 0.742 minus 0.700 into, see, it is your s square, that is your this is your sample variance. Okay, then how will you calculate the standard deviation? See, the sample variance is what? 1 upon n, small s is what? Sample sigma xi minus x bar squared. Okay, now you will write it like this, n minus 1 capital S square. So the capital S square upon n is what? S square upon n minus 1, small s square upon n minus 1. So here instead of capital S square, here what is given? Standard deviation, small s of 0.042. So we will write it like this, small s square upon divided by n minus 1, that follow a t n minus 1 degree of freedom. Okay, so t is what? Under root 9 into 0.742 minus 0.700 divided by 0.040, that will follow 3.15. So this is your test statistics. Okay, now so what is the degree of freedom here? So it will follow t n minus 1 degree of freedom, that is t distribution with 9 degree of freedom. Now Now if calculated t is greater than t naught, we say that the value of t is significant. Okay, what does it mean? It's mean that x bar differ significantly from mu and h naught is rejected at this level of significance. Okay, and what we conclude? We conclude that the product is not meeting the specification. Okay, or if t is less than t naught, t is not significant. Okay, and there is no significant difference between x bar and mu. Okay, I have to clear one thing. You will have a question in your mind that why I am using the small s square instead of the capital S square. See, in the questions, if the samples were given, then we will calculate the capital S square. But here, the small s square is given. What? The standard deviation of 0.04 inch. Okay, so how will you calculate it? So we have to find the relation and use that relations in this formula. That's why I have used the small s square. I will take another examples with the samples of 10 boys, and we will see how we will calculate the capital S square. Okay, so let's go to the second questions. Okay, so what is a random sample of 10 boys? Random sample of IQ of 10 boys, that is 70, 120, 110, 101, 88, 83, 95, 98, 107, 100. Okay, these, now the question is, do these data support the assumption of a population mean IQ of 100? Okay, we have to support it. Okay, so let me come to the solution. How will you solve it? See, null hypothesis is what? Mu is given, that is 100 in question. And what will the alternate hypothesis? Mu is not equal to 100 because we don't know anything about the alternate hypothesis. Okay, so what is the t statistics? So under h naught, test statistics is t is what? X bar minus mu divided by capital S upon n under root. Let follow t n minus 1 degree of freedom. Okay, now here x bar and the capital S square is computed from the data. Now let me draw the data. So x is given, we will have to compute x minus x bar and x minus x bar squared. 70, 120, 110, 101, 88, 95, 98, 107, 100, and total is 972. 27.2, 22.8. Take the sample, like when we divide 972 to by 10, you will get 97.2. Subtract it from there. It is a simple mean calculation. 3.8 minus 9.2 minus 14.2 minus 2.2, 0.8, 9.8 and 0.8, and it will equal to 0. And take the square of it, it will 739.84, 519.84, 163.84, 14.44, 84.64, 201.64, 4.84, 0.64, 96.04 and 7.84. It is 7. Okay, so what is the total? Total is 18.33.60. okay, so how will you calculate the s square? Let me add one more page. Yeah, s square is what? 1 upon n minus 1 sigma xi minus x bar square, that is 1833.60 divided by 9, that is 203.72. okay, yeah, 72. Now calculate the test statistics. T is what? 97.2 minus 100 divided by 203.72 divided by 10, that is equal to 0.62. okay, and T 0.05 at 9 critical value. We will take the help of the T value at 0.05. 0.05 at what? 95 confidence interval. okay, that is 2.262. okay, since calculated, it is for the 95% confidence interval. Since the calculated T is let me write it here. Confidence interval so alpha is not 95 confidence interval, but at alpha is equal to 5 level of significance. okay, sorry, 1 minute. okay, at 5 level of significance, and since the T calculated is less than tabulated T 0.05 for 9 degree of freedom, so H naught is accepted at 5% level of significance. okay, by mistake I have said about the 95% confidence level. It is at 5% level of significance. okay, since you can the level of significance, it is given in the questions. For example, if 1% level of the significance, then its value will be different. 10% level of significance, it will be different. okay, so how will you calculate the 95% confidence interval? So 95% confidence interval will calculate what? X bar plus minus T 0.05 is under root n. I have already told about the confidence interval, so you can watch that lecture. 0.154, that is 97.2 plus minus 10.21, that is 41, and 86.99. okay, this is for the T for a single mean. okay, where I have it, yeah, for the single mean. okay, now what if we have T test for difference of mean? T test for the difference of mean, then how will you see, I have already taught you this about in the previous lecture. I just give a small brief. okay, so suppose we have two independent samples x and yi of size n1 and size n2. These are size. Then the null hypothesis, under the null hypothesis is what? okay, so let me write it one formula. Under the null hypothesis, H naught, that the samples have been drawn from the normal populations with mean mu x and mu y. It is giving that the samples are drawn from the normal population with mean mu and mu xy, and population variance are equal. It is the assumptions, okay? That is sigma square x is equal to sigma square y, sigma square, okay? So the statistics T will be x was minus y bar minus mu x minus mu y, and S is calculated from the samples 1 upon n1 plus 1 upon n2. And what will it will follow? Sorry, it will follow T with n1 plus n2 minus 2 degree of freedom, okay? And how will you calculate the S here? So S square is nothing but 1 upon n1 plus n2 minus 2 into sigma xi minus x bar square plus yi minus y bar square. So this is for the t-test for the difference of the two mean. It is the same as the it is the same as for the this mean, okay? Okay, let me give me one example on this so that the concepts will more be clear. Suppose the samples of the two types of electric bulb were tested for the length of the life, okay? So where is type 1 and type 2? I only write the important data. Sample numbers were given. Here n1 is equal to 8, n2 is equal to 7, okay? Sample mean x bar given, sorry, not x bar, sample means were given. X1 bar is equal to what? 1 2 3 4 hour, and x2 is equal to 1036 hour, okay? And sample standard deviations were given, okay? 1 minute. Okay, sample standard deviation were given, that is S1 is equal to 36 hour and S2 is equal to 40 hour, okay? Now the question is the difference in the mean are significant to warrant that type 1 is superior than type 2 regarding length of life. See, don't confuse with type 1 and type 2 with the error. These are not that, okay? So since I will show you one important concept here. So what is the null hypothesis? Null hypothesis is what? Mu x is equal to mu y. But the alternate hypothesis is what? Type 1 is superior than type 2, means mu x is greater than mu y. So since information is given, if the data is saying that there is no information, like it is not written type 1 is superior than type 2, then what we will consider? Mu1 is not equal to mu2, okay? So what is the test statistics? We will use that x bar minus y bar. Here x1 and x2 are given. X1 minus x2 given s square of 1 upon n1 plus 1 upon n2 under root will follow what? T n1 plus n2 minus 2, that is T13, because 7 plus 8 is equal to what? 15, and 15 minus 2 is equal to 13, okay? Then s square is what? Plus n2 minus 2 x1 minus x1 square y1 square, okay? Then how will you calculate it? Just put the formula 8 plus 7 minus 2 into use that formula, that is n1 s1 square plus n2 s2 square, that is 1659.08, okay? Which formula I am talking about? I am talking about this one. Yeah, this one. I just use this one formula here. You can also use it because the sample distributions samples were not given. If the samples were given, then we will calculate it by this. Okay. Okay, so 759. Then just put the value here. Oh, I'm sorry. T is equal to 1234 minus 1036 divided by under root of 1659.08 5 into 1 upon 8 plus 1 upon 7, that is equal to 9.39. okay, so now we will text at the 5% level of significance. Okay. Now T13 at 5% level of significance for right single tail test is 1.77. okay. Okay, since see the in examination the level of significance value were given to you. Okay, so don't panic about that. Since calculated T, that is this one, 1 minute, is much greater than 1.77, so it is highly significant and H naught is rejected. Means two types of bulbs differ significantly. Okay, so our alternate hypothesis is true. Okay, now we will see questions regarding the F distribution. Okay. F distribution statistics test. Okay. Okay, so suppose we want to test two independent samples. Okay, two independent samples drawn from normal population with same variance sigma square. Okay, so under the null hypothesis, H naught, that is sigma square x is equal to sigma square y is equal to sigma square, population variance are equal, and the second is two independent estimates of population variance are homogeneous. So F statistics is given by S square S upon S square y. Now S square x is what? 1 upon n1 minus 1 sigma xi minus x bar square over n1. S square y is what? 1 upon n2 minus 1 sigma upon n2 into yi minus y bar. Okay, so this is your test statistics. Okay, now one more. How will you write it? Like you can also write it like when the sample deviation is given, S square x upon S square y. So you will write it what? N1 minus, just like in T distribution we have used, that is N1 S square x upon sigma square x into N1 minus 1 divided by 2 sigma square y sigma square y to 1 upon N2 minus 1. you can use this directly. Okay, we will see one or two questions so that it will be easily. Okay, so let me take one example. See, in one sample of 8 observations, in sample of 8 observation, the sum of square of deviation of sample values from the sample mean was 84.4. okay, or in other sample, 10 observation it was 12.6. Test whether the difference is significant at, we have to test difference is significant or not at 5% level. Okay, or it is given, see, it is given that at 7 and 9 degree of freedom it will 5% is 2.29. It is given that f critical value at 7 and 9 at this 5% level of significance is 3.29. Since it is given in question, so in examination it is given in question. Okay, so what is n1 is given 8, n2 is given is 10. Sigma x minus x bar squared is given as what, 84.4 given in question, and y minus y1 squared is given at 12.6 in question. Okay, just calculate s square x, that is 1 upon n1 minus 1 sigma xi minus x bar whole square, that is what, 12.057. just divide the 84.4 into 7 and s square y is what, similarly 11.4. now so h naught is what, sigma square x is equal to sigma square y is equal to sigma square. The samples are homogeneous. Okay, so the test statistics is what, s square x upon s square y, that is 12.057 divided by 1.4. let me write it more clearly. That is the estimates of sigma squared given by samples are homogeneous. Okay, that is 1.057. now tabulated value 0.205 at 7 and is given, that is 3.29. now we see that f is less than tabulated f 0.05. yes, 1 is less than 3, so h naught may be accepted at 5% level of significance. So the conclusion, what is the conclusion? So conclusion is the difference in sample variability is not significant is due to fluctuation of sampling. Okay, so h naught is accepted at 5% level of significance. So what will be the conclusion is that the difference in the sample variability is not significant. Okay, so this is for the f distribution. Okay, let me see. 1 minute just. I will see that if there is any own questions that can be. Okay, and now let's see one or two questions regarding the chi-square distribution. Okay, last concept, that is chi-square. I just give you one last, that is about the chi-square, and it is known as inference about a population variance. I will just give one example. Okay, suppose we have to test if the random sample xi xn from the normal population with a specific variance, that is sigma square is equal to sigma square naught. Okay, so under the null hypothesis, so h naught is what? Population variance is sigma square is equal to sigma square naught. So the statistic chi-square is nothing but sigma xi minus x bar square upon sigma square naught is nothing but 1 upon sigma square naught into sigma xi square minus sigma xi whole square upon n, and that is equal to n square by sigma square naught. Says these things I have taught in the sampling distribution part, so you can see that lectures for the better understanding. Okay, and it will follow a chi-square distribution with n minus 1 degree of freedom. Okay, let me explain this with the help of one example. Okay, so question: it is believed that the precision of an instrument is not more than 0.6. Means I will write only the important term. Precision of instrument is no more than 0.16. Okay, and test at 1% level of significance, and we have 11 observations. Okay, and the observations are 0.5, 0.3, 0.4, 0.3, 5, 0.7, and 6, 7, 0.5. Okay, so what is the null hypothesis? Okay, since the null hypothesis is what? Sigma square is equal to 0.16. Why? It is given that the precision of the instrument is not more than 0.6. Okay, so null hypothesis is what? Straight, and what will the alternate hypothesis is greater than 0.6, because it is written precision of the instrument is no more than means sigma or 0.6. Okay, now let's calculate the sample variance. So x minus x bar and x minus x bar whole square. So what are the value? That is 2.5, 2.3, 2.4, 2.3, 2.5, 2.7, 2.5, 2.6, 2.6, 2.7, 2.5. X minus x bar, just take the mean, and the mean is what? Nothing but 2.51. Subtracted, minus 0.01, minus 0.21, minus 0.11. Okay, minus 0.21, minus 0.01, plus 0.19, minus 0.01, plus 0.09, plus 0.09, plus 0.19, minus 0.01. Okay, take the square. 0.001, 0.0441, 0.0121, 0.0441, 0.0001, 0.0361, 0.001, 0.0081, 0081, 0.0361, 0.0001. Okay, and what is this? X minus x bar square is what? 0.1891. Okay, now the null hypothesis is what? Mu is sigma squared is equal to 0.16. so just test statistics is n squared upon sigma square, sigma x minus x bar square upon sigma square, that is 0.1891 divided by 0.16, that is 1.182. Okay, so chi-square with 9 degree of freedom, sorry 10 degree of freedom, because there is 11 observations, so 10 degree of freedom at 1% level of significance. Okay, so what is the, so its value is 23.2. okay, so the calculated chi-square is less than tabulated chi-square. Yeah, it is, you see it is 1 and it is 23.2. Okay, then what will be the conclusion? The conclusion, it is not significant. Okay, okay, H naught may be accepted. Okay, so this is about the chi-square test. So the syllabus for your jam is completed. Okay, if any questions in the PYQ is left, I will solve it and then send to you. Okay, so this is from my side. Thank you. Okay, so good afternoon, students. So student, we today we will going to solve the PYQ IIT jam economics question, okay, of the hypothesis testing. Okay, so we will solve hypothesis testing question paper. Okay, so let me start. Okay, so let's see the first question. So in a statistical hypothesis testing, the area of non-rejection. So see, when I have already told in a class, if this is, sorry, 1 minute. Yeah, this is the whole sample space. Okay, and this is your critical region and this is your acceptance region. Okay, so what is asked in question? The area of non-rejection region is defined. Okay, so first of all, see the options. It is written in terms of the type 1 and type 2 error. Okay, so what is alpha? Alpha is probability x belong to critical region given h naught, means probability reject h naught when h naught is true. Okay, so and what we have to, it is critical region. Okay, and what we have to find? Non-rejection region. Non-rejection means the complement one that we know as acceptance region. So how will you find it? 1 minus alpha, because 1 minus probability x belongs to critical given h naught, that is probability x belongs to acceptance region given h naught. So what is the correct option? 1 minus probability of rejecting null hypothesis when it is true, that is the correct one. Because see, 1 minus probability of non-rejecting the null hypothesis when it is 1 minus beta. It is a power up test. Probability of rejecting null hypothesis when it is true minus probability, no, it is wrong. The probability of rejecting null hypothesis when it is true, it is the critical region. So the correct option is first. Okay, see, this is a very easy question. It is just based on the definition of the null, the definition of the rejection region. Okay, now move to the next question. Yeah, so this is a from this inference paper. Okay, I am also taking all the inference paper in this. So what is this ask? If beta is the consistent estimator of the population meter beta and epsilon and delta are very small quantity, then which of the following is true? So when you see it, and estimator beta is consistent for beta if for or epsilon greater than 0, limit n tends to infinity, probability of b minus b is less than epsilon is equal to 1. Okay, now as sample size increases, means if n tends to infinity, no, okay, as n tends to infinity, probability that beta lies within any small distance of epsilon of b, and it goes to 1. Okay, so which is the correct option? It goes to 1, then the correct option will be this. Basically it is also the direct formula of the consistent estimator. Okay, when you say in the book, then it is the formula of the consistent. You don't have to go to this concept. If you know the formula of the consistent estimator, you just see the question, take it and just move forward. Okay, okay, now power of the test. Power of the statistical test is simple. I have shown in the first question. 1 minus probability of non-rejecting the null hypothesis when it is not true. So this is the power of test, because it is probability x belongs to critical reason acceptance given h1, that is 1 minus beta. It is the power of the test. So the correct answer is B. Now move to the next question. Which of the following is a non-parametric test? So you have to find out which of these is a non-parametric test. So see, t test is what? T test follow normal 0 1. Okay. F test also follow the normality conditions. Z test also follow the normality condition, but chi-square test does not follow anything. It is a, so I am not talking about chi-square distribution. Okay. No, it is test. See, because x minus mu naught s upon n. Okay, so non-parametric test is chi-square. So chi-square is a non-parametric test. Okay, it does not assume anything about the distribution. Move to the next question. Yeah, 36. It is a very good question. See, and it is in an it is MSQ types question. What is asked? If x1, x2, xn with a random sample of size greater than n drawn from a probability distribution having mean mu and non-zero variance sigma square. Okay, an important concept is there is not, it is not given normal. Okay, normal not given. What is given is from a probability distribution with mean mu and non-variance sigma square. Does not assume that the mu and sigma square are given, then you should take the normal. Okay, it is not normal. Okay, always kept in mind. If it is normal, then normal distribution should be written here, but it is not written. It is written probability distribution, so it will follow sorry, it will follow any distribution. Okay, so let's start. So the sample mean has a standard deviation sigma yn. Yes, it is true. Why? See, because sample mean is what? Sigma xi upon n. Okay, and variance of x bar is what? Sigma squared n. So standard deviation of x bar is what? Sigma upon n, and this hold for any distribution with finite variance. So it is a correct one. Okay, then move to the next. The probability distribution of tends to the normal. Yeah, it is simply this central limit theorem. It is a central limit theorem, so it is also a correct one. Okay, and what is now n minus 1 sigma square will follow chi-square distribution with, no, it is not, because for chi-square distribution x follow normal 0 1 or x follow normal mu sigma square, but it is not given here. Okay, when it is true only if the population is normally distributed. Okay, that's why it is wrong. The sample mean is always a consistent estimator. Yeah, it is true. Why? By law of large number, by LLN, law of large number, x bar tends to mu. Okay, so it is also true. So the correct option is A, B and D. Okay, now move to the next question. What it is asked? Now what is asked? The value of the random sample drawn from the normal distribution with mean. Yeah, see, given normal distribution, so normal 5 and sigma squared, it is 5. Okay, and samples were given 4.8, 4.5, 5.1, 5.2, 5.3, 5.5. Then the MLE estimate of the sigma square. See, I have already told in the class how you calculate the MLE estimate, so I'm not going to calculate the MLE estimate here. You know just MLE square, and you should learn. Okay, because in examination you don't get that much of time to estimate the MLE for mu, for sigma square. Okay, so at least you should not learn the MLE estimate of the normal distribution. Okay, so but you can calculate it. If you can't learn, then you can calculate it. See, the MLE estimate of the mu bar is x bar, so sigma square is 1 upon n sigma xi minus x minus mu square. I have already told in the class in the inference that how will you calculate it. Okay, so this is the formula. Just you have to calculate it, the deviation. So what is 4.8, 4.5, 5.1, 5.2, 5.3, 5.5. Calculate x minus mu, that is 0.2. What is mu here? Mu is 5 given, so x minus 5, 0.2, 0.5, 0.1, 0.2, 0.3, 0.5, and x square it. What is this? 0.04, 0.25, 0.01, 0.04, 0.09, 0.25. Okay. Now add it. What will you add it? It will be 0.68. Sigma square will be what? 0.68 divided by 6, that is 0.1133. So this is your estimate. Then how many? Yeah, round up to decimal, then answer will be 0.11. Simple. Okay. Now this is a good question. What is it? See, the probability density function of the continuous random variable is given. So it is a exponential distribution. If lambda is greater than 0 and the observed samples, see samples were given, find the MLU of the lambda square. Okay, so given fx lambda is what? Lambda e to the minus lambda x. 1 minute. Lambda x is greater than 0. How will you find the MLE? Okay, in this question I will show you how to find the MLE. Okay, so see, first of all, take the joint distribution, that is lambda n e to the power minus lambda sigma xi. Okay, taking the log both sides, that will equal to, that is L is equal to n log lambda minus lambda sigma xi. Differentiate log L with log lambda, that is n upon lambda minus sigma sigma xi is equal to 0. Okay, this is how you calculate. Put this, n is equal to sigma xi upon lambda, so lambda is equal to n upon sigma xi. How many numbers in 5? Add this 1.7, 2.25, 2.50, 2.75, 3.25. Okay, that is 12.5, that is 0.4. Okay, and now value calculated, you will get 2 by 5. So which of the, yeah, D option is the correct. Okay. Okay, now move to the next question. Yeah, so with 5 is the proportion of the population vaccinated against a disease, an estimate of, and if estimate is given 0.64. It's found using a sample of 100, n is 100 individuals from the population. If Z statistics, the null hypothesis is, what? 0.58. Okay. So what is the Z test statistics? So you have to find the Z test statistics. Null hypothesis is given. Okay. So what it does in statistics? The proportion is what? 1 minus, sorry, P naught by n. It is a proportion. Just keep it. What is? Okay. This is a proportion. Now, what is given? 0.64 estimated minus 0.58 divided by 0.58 into 1 minus 0.58 into 100. When you calculate it, we will get around 0.06 into 0.4049, and when you calculate 1.22, so the test statistics 1.22. The answer is 1.22. Simple, just to remember this formula, you will get it. Okay, now move to the next question. In the hypothesis testing, which of the following define the size of the power of the test? Simple, the size of the power of the test is what? So power of the test is 1 minus beta. So which is the following represent the 1 minus beta? So when you see probability of accepting null hypothesis when it is false. So accepting null hypothesis when it is false is what? Type 2 error. Okay. So 1 minus beta. So this is the power of the test. Okay. Simple question. Only you need to know the formula of the alpha, beta, type 1 error, type 2 error, or 1 minus beta power of the test. Okay. Now move to the next question. Okay. Okay. So this question is what? So when you look at this question, you will get to know that when x is uniformly distribution with a random variable 0b. Okay. 1 minute. Sorry, I'm not feeling that much. Okay, so yeah, I'm sorry. So x follow uniform 0b. Okay, and if the critical reason is for testing the null hypothesis is null hypothesis 2 against the alternate hypothesis is, okay, and it is a critical reason, means x is less than 0.1 or x is greater than 1.9. okay, and only single value, then what is the probability of type 1 error? You have to calculate the type 1 error. Okay, so what is type of error? Type 1 error is probability of x belong to critical region given h naught, or it will equal to probability reject h naught when b is 2. Okay, b is h2 means h naught is true. So when the h naught is true, that is beta is equal to 2. Okay, so just take uniform. What will be the next one? Uniform 0 b. So we have to calculate for h naught, that is equal to uniform 0 2. Okay, so what will the fx is equal to 1 upon 2, that is 0, x is greater than 2. Now x is 0.1, or see here, or is given, x is greater than 1.9. So we have to calculate for this. So probability x is less than 0.1, what do we want? 0.10 1 upon 2 dx, that is equal to what? 0.1 upon 2, that is 0.05. 1 minute. 0.5. Okay, and probability x is greater than 1.9, that is 1.9 1 upon 2 dx, that is equal to 0.1 upon 2, that is 0.05. So what is the type of error? So this is odd, then it will be union. Okay, so 0.05 plus 0.05, that is 0.10. So the correct answer is 0.10. Oh, that is, yeah, 1. I just forgot. Okay, so let's move to the next question. Yeah, this is very important question. What? You will learn a new concept here. See, it is IIT Bangalore, so IIT Bangalore will always ask a very good question. Okay, what is asked? If x is uniformly distributed random variable with with a and b. Okay, the value of an independent drawn random sample size of 5 from the x variable given what? 1.3, 0.8, 9.5, 20.2 and 8.2. A and B will denote the maximum likelihood estimate of the parameter A and B. Then A will be. So first of all, I will let you know how you can calculate the MLE for the uniform distribution. Okay, so let's please start. I think I should use some different color. Yeah, blue is the good. Okay, see, let x1 x2 dot xn be a random sample from the uniform distribution with PDF. Sorry, fx theta is equal to 1 upon theta infinity, and theta is greater than 0 and 0 otherwise. Okay, we have to calculate the maximum MLE of theta. Okay, how will you calculate it? See, when you use the procedure of the MLE, so what is L? L is equal to pi fxi theta, that is 1 upon theta to the power n. And when you differentiate it, okay, first of all take the log L, that is n log 1 minus log theta. Okay, now when you differentiate it, what will you get? 0 minus 1 upon theta. Okay, that is equal to 0. Sorry, n theta, that is 0. It's an absurd result. We can't do like this because it's an absurd result. We will not get any result of this MLE. So in this case, we locate MLE as follow. Okay, we have to choose theta so that L in this case, let me one, L in 1 is maximum. Okay, and L is maximum if theta is minimum. Why this? Because see, if L is maximum, because L is what it is, if it is less than, then it will be equal big. So we will use the concept of order statistics. If you don't know the order statistics, then don't worry, only just need here. Order statistics, what? The random variables are in this order. X1 is less than x3, x1 is less than x4. Okay, done. Okay, okay, so that we have an order statistics. And how will you will write like this: x1 x2 dot xn is less than theta. Okay, where theta is greater than xn. So the minimum value of the theta consistent with the sample xn, since minimum value of theta consistent with sample is xn, or the largest sample is xn, so MLE of theta is equal to xn with the largest sample observation. It is when the theta is from 0 to infinity, means theta is 0 to infinity. And in question what is asked you in AB, so I will going to prove for the AB as well. Okay, it is for theta is this, so this is the MLE. Okay, let me do here. Okay, now when we now we have fx alpha beta. Okay, that is 1 upon beta minus a alpha x minus beta. Now okay, this is case 2. Same question, if you take the log L, I will just type directly log beta minus alpha, and when you differentiate it you will get log beta minus alpha is equal to 0. That is absurd. Then how will you use it? We will use the same concept of the order statistics. Okay, using same concept that I have used above, order statistics. Okay, now alpha x1 x2 x3 dot 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 xn is equal to beta. Thus beta is greater than xn and alpha is less than x1 is the minimum possible the minimum possible value of beta consistent with the sample is x, and our maximum possible value of alpha consistent with sample is x1. Okay, so alpha is what? X1. Direct results are there. Beta is what? xn b MLE when x follow uniform AB. Okay, now same concept we have to use here. So alpha A is what? X1 and B is what? xn. Arrange this in an order statistics. Okay, so what you have to do, you have to arrange it. Okay, so when you arrange it, what we have? 0.8 is greater than what is 1.3 is greater than this happened, then 8.2, 9.5, 20.2. it means ki A 0.8, 1.3, 8.2, 9.5, 20.2, B. So A is what? 0.8 and B is what? 20.2. If you know the concept, you will just get the answer correctly, and the correct answer is what? Yeah, first one is the correct answer. I hope you understand. Okay, thank you. Now the next question is, so I think this is the last question. If x1, x2, xn are the independent random variables with the standard normal variation or standard normal distribution, means all x1, x2, x3, x4 follow what? Standard normal 0, 1. Okay, and y is what? x1 plus x2 squared plus x3 plus x4 squared. Okay, and we have to find the variance of the ay. This is very easy question. Okay, see, x1 plus x2 follow what? Additive property of the normal distribution, that is 0, 2. Okay, let me write it. Additive property of normal. Okay, and x3 plus x4 follow what? Normal 0, 2. Okay, now what do you know? You know one thing is what? If z follow normal 0 sigma square, and then z minus 0 upon sigma whole square will follow what? chi-square with 1 degree of freedom. So x1 plus x2 follow normal 0 2, then x1 plus x2 divided by 2 whole square will follow what? Chi-square with 1 degree of freedom. Okay. Oh, sorry, it is 2 now. Yeah. Oh yes, under root 2. I'm sorry. Under root 2 follow chi-square distribution. Then x1 plus x2 follow what? 2 chi-square 1. Just 2 kept it here. Equal to. Similarly, x3 plus x4 square follow what? 2 chi-square with 1 degree of freedom. Now, let me do it here. Y is equal to what? X1 square plus x2 square. That is 2 chi1 square plus 2 chi1 square. Okay. That is equal to, take the 2 common. Now chi square with 2 degree of freedom, just write like this 2 plus 2 4. No, you have to take the common. Okay, that is chi square with 2 distribution. Now if y follow 2, take the 2 as common, chi square with 2 freedom, then what will be the mean of the chi square? So the variance of the chi square is what? Okay, then the variance of the chi square 2 is what? 2n. That is 2 into k is the degree of freedom. 2 is 2. 2 into 2, that is 4. N is what? Degree of freedom. Okay. Now it is 4. So take the variance of y. So variance of y is what? Variance. Sorry. Let me erase it. Yeah. So variance of y is what? Variance of y is 4, because when you take the variance, 2 will be 4 into 2n, that is 4 into 2 into 2, that is 16. So the correct answer is 16. Okay, so this is the last question. See, all the questions that is coming from the statistics portion economic is easy to moderate level. Okay, you don't have to be very panic while solving these questions. Always read the questions properly. Okay, and you will find that most of the options were given in the question itself. Okay, see, from the inference part, or we can say that hypothesis testing, only the theoretical questions has been asked. Okay, so make your theory properly. Okay, so this is from my side. Thank you.